Today we're going to be going over quicksort, and we are walking through each step while highlighting the code execution, also using recursion. We begin with the array 2, 9, 4, 3, and 7, executing the main method calling quicksort on the array in the parameters 0 and 4, which is the array length -1. The main idea of this quicksort method is to recursively divide the array into smaller subarrays based on a pivot element for sorting. Since 0 is less than 4, which is the low less than the high, we go into the partition method with the same parameters. The idea of the partition method is to take any elements less than the pivot and move them to the left of the pivot, and any that are greater than or equal to the pivot, move it to the right. Now going into the for loop, j starts out at 0. Is 2 less than 7? In this case it is, so we're going to increment I and then swap the values at I and j. Well, I and j will both be equal to 0, so we just swap 2 with itself and it just stays in the same place. Increment j, now we ask is 9 less than 7? It is not, so we don't do anything. We just increment j. Now is 4 less than 7? It is. We will increment I and then swap the values at I and j, so we'll be swapping the indices 9 and 4. We're going to increment j again. Is 3 less than 7? It is. We'll increment I, and we'll end up swapping the values 9 and 3. Increment j. We are now out of the for loop, and we're going to swap the values at I plus 1 and the index of high, which is 4. So we'll end up swapping the values at 3 and 4, which will be 9 and 7. And we return I plus 1, which is 3. Now that we have a pivot index of 3, we're going to call quicksort on the array. The low is still 0, and the pivot index -1, or 3 minus 1, which is 2. Well, 0 is less than 2, so we go back into the partition with the low being 0 and the high being 2. Back to the for loop for the next recursive call. J starts out at 0. Is 2 less than 3? It is. We will increment I and then swap the values at I and j. Again, we're just swapping 2 by itself. Increment j. Is 4 less than 3? It is not, so we just increment j. We are now out of the for loop, and we'll swap the values at I plus 1 and high. So this will be the values at 1 and 2. We now return I plus 1, which is just 1. The pivot index for this call is 1. Now we go down to the next quicksort, passing in the parameters array 0 and 1 minus 1, which is just 0. Well, this time the low and the high are both 0, and 0 is not less than 0, which means we are done with this recursive call. Now that we reach the end of this recursive call, we go back up and call the second quicksort, where we return 1 for the pivot index, and the high for that pivot index was 2. And for this pivot index, we say 1 plus 1. So that is 2 when we call its quicksort. Now we pass in the parameters array, low of 2 and a high of 2. Well, 2 is not less than 2. So we get out of this recursive call because we can't go any further. And we go back up the activation stack one more time, where initially we returned 3 for the pivot index and the high was 4, which means we call the second quicksort passing an array, the pivot index plus 1, which is 3 plus 1, and the high of 4. We check if the low is less than high. Well, 4 is not less than 4, and we can't go up the stack anymore, so we are done with the recursive calls and have a complete quick sorting algorithm. Remember that a key difference between this sort and merge sort is we swap elements and order them before we go down another recursive call, whereas merge sort goes all the way down until it reaches a base case and we can't divide it anymore, and then sorts the elements as it works its way back up the activation stack.